Today, I want to talk about behavior-driven development, BDD. First, I'm curious about, I think everybody here, I don't know if you're familiar with BDD, behavior-driven development or not, whether you've used it or not. I've been talking about BDD for a pretty long time, uh, well over a decade now. I was introduced to it not long after it was formulated back in 2006. And many, many years ago, um, over a decade ago, I wrote a blog post, 10 Reasons Why BDD Changes Everything. And it was the most read blog post that I ever had. As far as, I posted 100 blog posts, over 100 blog posts over the years. And so it kind of struck a nerve with people. I think it's the right thing to do. I think it's always been the right thing to do. I think it's the best thing that we have. It's as close as to a silver bullet as we're going to get in software development. So if you want to find that, you can find that on my website. The nice thing about if you're interested in finding me or linking into me is the fact that there's only one Larry Apke who's alive. So all you got to do is do a Google search on Larry Apke and you'll find me. Um, I'm purposely not including information. There's information here about how to get in touch with me, but like I said, you can just Google Larry Apke if you want to get in touch with me or find the things I've done. I've got a lot of the materials that I've done over the years on YouTube. When I left Job Hackers, which is a nonprofit that I founded and ran for about 7 years, and still going on today, after I resigned, I took my materials and I made them open source and put them up on YouTube. So if you're interested in the class and how the class was when Sadir took it, it's all out there for you to find. But what I want to talk today, I want to talk about not the 10 reasons why BDD changes everything. I think those things are still appropriate as they always have been. And I think my class is still appropriate. I think the issue is in the age of AI, the things that I taught, particularly BDD, are more appropriate now than they were a dozen years or more ago when I started doing this stuff and presenting it to the world. So that's why the title of the presentation is not only why BDD matters in the age of Agile, but it matters even more. And I'll make an argument for why that is. But the subtitle is When Code Becomes Cheap, Behavioral Precision Becomes Priceless. And that's what it is. It's about describing the behavior of systems. So I have purposely not included any information about my day job. I don't want to talk about my day job. I don't. It's fine. There's nothing wrong with it. It's just I like to keep it. Companies, get a little squeamish about it. So if I talk about things, I want to emphasize the fact that I'm presenting stuff that I've done on my own, experiments that I've run, and things that I've learned. And if I answer any questions in the future, they won't be questions that are particular about my day-to-day job. But before we get started, I want to take you on a little diversion, if you'll indulge me a little bit, because the Agile MBA class, we've also called it other things like Agile Mindset and other things over the years. I think, again, is really important information because I think that the main thing that we need to do in this world, which some of you might be familiar with the term VUCA, which means volatile, uncertain, complex, and ambiguous. We live in the VUCA world. And with AI, it's becoming more VUCA every day, right? We don't know where AI is going. It's volatile, uncertain, complex, and ambiguous. So how do we deal with that world? That's not the world that we evolved for as human beings. And so my diversion is basically what I cover in the first part of my class in that Agile MBA to give you some context, because the BDD stuff that I'm going to talk about, that's part of the class. And so they can't, I don't think, be teased apart. The second reason is I think the key to success as human beings, or at least optimization, is we have to start seeing the world differently. And so the quote below is actually, I was looking for a better quote, is a quote that I generated, and I don't know if it will get any traction, but to solve things differently, which we need to do in this age, we need to first perceive things differently. And so I want to take a little bit of a diversion into what I cover in my opening. So I want to start with y'all with a thought experiment. And I want you to imagine, and you can close your eyes if you want to, if it helps you imagine. I want you to imagine a world before the microscope existed. And if you can do that, I want you to think about what did it look like? I don't know the exact years, 1500s or something like that. What did the world look like? And then I want you to think about the day after the microscope was invented. And I want you to ask you the same question. What did the world look like? And I'm sure the answer, I mean, I've got my own perception of it. It's people in, thatched roof houses and horses on the street and carriages, maybe, people wearing clothes that are not designer fashions, etc. But the key is it hasn't changed. It doesn't change much objectively. The outside world doesn't change much, but we can only see things with our naked eye. That's why the picture of the big eye, I don't want to just freak you out or anything, is we see things with the naked eye. After the microscope is invented, the world hasn't changed much, right? The world outside of human perception hasn't changed much, but what has changed and what is fundamentally different is the human perception has changed. Our ability to access the world. So when we looked at a drop of water before, it was merely just a drop of water. Once the microscope is invented, we can look at that drop of water, and what we begin to see is we begin to see things that we never saw before. Right? We didn't see this. This is probably a scanning electron microscope, if a real picture at all. But we saw things in that drop of water. We saw the things that you learned about in your biology classes in high school, the paramecium, the euglena, and amoeba, and all these things. They were always there, right? The world outside our perception didn't change at all. But our ability to see the world differently changes everything, because now we have different lenses. And that's what I'm going to talk about today. And I talk about a lot in my class is lenses, or something that we refer to as mental models. We're going to need new mental models around AI, and they're starting to be formed now. If we use the existing mental models in our relationship with AI, we're going to have some issues. And I'll talk a little bit about that. So I want you to think about that. Different lenses allowing us to see the world differently. And for human beings, it's not only these physical lenses, but we have mental lenses that we call mental models. And BDD is one of them, right? Um, if you don't like that one, I'll give you another one, because I think it's the same kind of concept. This is what I saw when I was a kid growing up. This is what I refer to as the night sky, and I grew up in the suburbs, a city called Cincinnati, Ohio. I don't even know if you're familiar with it, but when I would play as a kid and I'd look up at the sky, I'd see something like this, and there'd be light pollution and other things. Now, some of you might live in places that don't have the light pollution and other things, and when you look up at the sky, you see something that looks a little bit more like this. I didn't see this until I was, in my 30s. I didn't know it existed, right? So the ability to see the world differently changes things. When I saw this, I even doubted what I saw, right? I saw it with my own eyes, but I doubted it because I had never seen it before. So I think when we start to talk about things like BDD and AI, I think we have to realize that there are some fundamental shifts that we need to make in the mental models that we use. And if we don't make those fundamental shifts, I don't think it's going to be catastrophic necessarily, but we're certainly not going to be optimal. This is the thing about the VUCA world, by the way. The VUCA world is there's no guarantees that you're going to be successful, depending on how you define it, because you can do everything right and still not be successful in the VUCA world, and you can get lucky, and sometimes we get lucky and we think we're doing the right things. We don't know. So with that as a diversion, to set up this talk. Now I want to talk about why BDD matters even more and why it's so important to what we're doing in the world today, especially with the world of AI. So I want to talk about BDD and where it came from. And the environment with it was for years and years, the hard part and the expensive part of software development. And I'm going to talk particularly about software product development. I think that's what you all are into. It's what I've been doing for decades now. Writing code was the expensive part. Software developers were scarce. They were expensive. They were hard to get, and writing code was very expensive. And that's the world before AI. But the world has fundamentally changed, right? We know that. Anyway, BDD was invented way back in 2006. And I think I started getting involved with it a few years later by a gentleman named Dan North and some of his colleagues. And BDD was there to try to help people clarify behavior of systems, reduce misunderstandings, and make sure that we're aligning the business needs with what is actually being developed in the software. Because behavior is something that a product manager or product owner understands. They don't necessarily understand the technology. So BDD was meant to be that bridge. But along the way, it wasn't used that much, unfortunately, because a lot of developers saw it as overhead. A lot of developers saw it as just, ceremony or something that was extra documentation that was not necessarily needed. I disagree with that, but I think BDD hasn't been as successful as it probably should have been. And this is in the world, for me, I came into it from the world of Agile. So if you think about software development and waterfall, things were very slow. And you didn't write a whole lot of code, not a whole lot was getting done. When we brought in Agile, you started being able to write code faster. But the other thing that you start writing, if you're not careful, is technical debt. You start introducing defects and other things because quality is not something that you can inspect into your product, which is a mental model and lens that I want you to understand. Quality is something that you have to build into your product. The quality is going to be there or not there by the time it comes to inspection. But what most software product development places do is they do QA, but it's just mostly inspection. Meaning I'm going to write some code and then I'm going to see if it works. And that's problematic. And it was problematic back in 2006, which is why Dan North came up with BDD. And it remains problematic today, even before AI. But there was a bottleneck and there was a natural braking mechanism. And that natural braking mechanism was that code was expensive. And because it was, we could only hire so many developers and et cetera, et cetera. So it wasn't that big a deal until now. It's a much bigger deal. AI made code cheap. And it does. And I've used it. I'm going to show you some of the ways I've used it. But the world changed quickly. And this is the example, as I was saying before, the world is VUCA. Volatile, uncertain, complex, and ambiguous. Nothing more than AI tells us this. The question that we should be asking ourselves is, if the world is VUCA, if you agree with me, then what do we do to be successful? How do we become optimal in that world? BDD is just a part of that. There's a one-word answer that I'll give you, and that answer is feedback. Right? When I teach my class, I talk about if you want to be successful in the VUCA world, you need fast, accurate, actionable feedback. And if you remove feedback from your system, what you're doing is you're increasing risk. And that's a problem because, anyway, I'm going to go further. So what changed? The bottleneck moved. It moved from writing code to describing behavior precisely. This is what I believe to be true. I now have, and I've done this, and you've probably done this, I can go into AI, I can say, AI, here's what I want. And AI will write some code. Now the question is that code quality code? Is that code something that's going to help, if I put it into an enterprise product, does it have ticking time bombs in there? Don't know. But one of the things that we've done is we can write code fast enough to keep up with any request now that the business might have, I think, with AI. But I think we have to be careful because we started out with waterfall, we were slow. Agile might have sped it up 2 times, but AI is going to speed it up 100 times. And you got this thing called vibe coding, right? You're probably familiar with that term. You got people in there who are coding who know nothing about the code, the underlying code. This is problematic to me. How do we then, if this is the way the world is going to be, how do we make sure that we don't run into problems? So before AI, code was expensive. Humans actually had to talk together, right? If they hopefully talk together and interpret intent. And because the intent, a lot of times, from what the business was asking for and what development understood, was a problem, we had ambiguity. So the ambiguity had to be removed. BDD is a way to remove that ambiguity. But now we don't have that problem because what happens, code is cheap now. I can produce a lot of it, and I have using AI. And I know enough to be dangerous about software development. I'm not as good as probably you all are, but I know it's writing a lot more code than I need. But what I'm using it for is not for production code, right? I'm using it to create prototypes and other things that I'm just going to throw away. It's very good for that, but there's no way I'm going to deliver the stuff that the AI is writing for me, because I know it's not quality. AI executes the intent, and here's the big problem. Ambiguity scales instantly, meaning that if I have instructions that I'm giving to AI and that's ambiguous, you all know what AI is going to do, right? Because AI is a fancy pattern recognition machine. It's going to give you an answer. It's not going to say, I don't know. I don't think. Maybe it does. I haven't had it do that. Usually it just tells me how wonderful my idea is, which is its own problem. But it's going to take this ambiguity, if there's any that exist, in what you're telling it to do, and it's going to make a decision, but it's not a human decision. So when we remove humans from the loop, we've got an issue because the biggest part of BDD was the conversation that happened from creating BDD scenarios and then working through that ambiguity with a human being. We don't have that anymore if we're using AI, right? AI generally, maybe AI will ask questions for clarification, maybe it won't. We don't know, right? So machines are not going to always understand human nuance. They're going to only understand, they're only going to match patterns based on what you put in there. So what matters most of all is if we're going to use AI, we need to have behavioral precision and how we describe what we want to achieve. And if there's any ambiguity and there's little or no behavioral precision, we might create code that works, but we're not going to create good code that lasts. And to me, that's a big problem. So I've always been very interested in this concept of technical debt, which I think you're probably familiar with. What we're going to do, my biggest fear about AI and coding is that we're going to create a lot of technical debt very quickly. In fact, I know we will because I've studied human nature. There's a big push in a lot of organizations. I'm here in the San Francisco Bay Area, so it's probably the epicenter of everything. We had a party the other night, and we had an AI table where a bunch of people sat around and talked about AI. Right? It's everybody's talking about it. It's taken over the world. But the problem is we're creating ticking time bombs. Because unless we start getting very, very explicit about what we want from our systems, AI is going to make decisions, quote unquote, that are probably not what we want. And in the short run, the problem with quality issues is that the quality problems and the technical debt doesn't always get us right away, but it will get you. It's just a matter of time. It's a ticking time bomb. So one of the things I tell a lot of people, especially developers, when they say, well, there's not a lot of software developer jobs anymore because it's being replaced by AI. That may be true in the short run. But if you're a good software developer, somebody's going to have to diffuse those ticking time bombs that are being put in today as we speak. And at a great scale. We were always putting ticking time bombs into our code, but now we can do it pretty easily. So BDD matters even more now than when I started talking about BDD, not less. It doesn't go away. The need to be able to converse in a way that AI we can keep AI on the reservation is a word I would use. Keep it from going off and hallucinating and other things, which is impossible, but we can do better. So I want to use a few metaphors. When I talk about mental models and lenses, I want to use a few metaphors for what's going on here. BDD is like DNA. It describes the person, right? So I don't know if I'm familiar with genetics and epigenetics. It describes the person, but you're going to be different based on your environment, right? But it basically describes this is a blueprint. Or you can use BDD as the example of here's the blueprint for the house I'm building. You can use BDD as it's the recipe for the meal, which I think is a pretty strong metaphor because you might have a recipe and different chefs end up cooking it slightly differently, but it's still, you can recognize it as, this particular dish. The metaphor I'm going to use going forward, I think, which is the best one, is BDD, and that's why I have the picture here, is the mold that we pour the code into. And so if we create a good mold, we're going to have a good code, right? And we could do more if this is true. So AI increases the value of what I'm going to refer to as behavioral precision, which is what we get through using BDD. Here's the thing. I'm in good company. It's not enough. I doubt any of you are familiar with me, even though I've been around and done quite a few things. You probably haven't heard my name before, but you've heard of a little organization called Amazon, I think, and they do a pretty good job, by the way, of software development. I don't know if I'd actually want to work there, but they do a good job of software development. When they created an AI IDE, which is called Kiro, they built into it specification-driven development, which is what BDD is to a certain degree. They use something called ears, which looks a lot like BDD. And so we have a friend, one of the people who was at our party at the AI table, she contacted me a couple of weeks ago, which is fortuitous for this presentation. And she mentioned this thing about Kiro, and I had to look into it because she said something about ears, and I had never heard of ears. And that's not for lack of looking, because this is kind of the thing that gets me excited and gets me up in the morning. It's basically, EARS stands for Easy Approach to Requirements Syntax. And it's very, very similar to BDD. But the interesting part is that everything that Kiro does is generating this acceptance criteria. We refer to it sometimes as acceptance test-driven development, right? Not just behavior-driven development. So this is BDD. If you're not familiar with it, now I'm going to show you what BDD is. It's very simple. We say we have some givens. What state is the system in? Something happens to the system. If nothing's happening to the system, then we don't have any functionality, so it doesn't matter. But something happens to the system, and then the system behaves in a certain way. It's very simple, by the way. And every system is this. You can describe any system that does something, any software system that does something with BDD. Now, sometimes you might be stretching it, but you can, because everything it's in a given state. Something happens to it, and there's a reaction to it. That's every system. It's basically, when I teach this in class, I show a box with two arrows, one going in and one coming out. That's every system. Input, throughput, output. Given, when, then. If you look at a class, software class, what is it? It's given, when, then. What am I pulling in? What are my prerequisites? What am I doing to it? I'm multiplying two numbers, and then I'm sending back some kind of return value. So even at the class level, when we look at methods in a class, it's exactly what we're doing. So this is BDD, and it's very, very powerful because we're using human understandable English to create these scenarios. We're not using anything else. And if you look at all architecture, by the way, all software architecture is nothing more than these boxes of input, throughput, output, and how they're arranged. So your entire system can be understood in BDD. Now, ears, which comes to us from Rolls-Royce, actually. So Dan North put BDD together as a kind of a thing in 2006. This came later. I think it was about 2011, where ears comes into play. This easy approach to requirement syntax. It comes to us from Rolls-Royce, and the reason that they did it, it was more hardware. It was jet propulsion, that kind of thing. So it comes to us from a different place. This is not unusual in the world of science, right? We have different people solving similar problems in similar ways. It's just ours. We were solving a software problem. They were solving more of a hardware problem. But look, I want you to look at the syntax of ears, because it says while some precondition exists, when something happens, then the system shall respond. It's almost exactly the same. And why they chose ears and not BDD, I'm still doing some research. My understanding from doing the research, at least initially, because it's relatively new to me, is that ears seems to work better. Or their conclusion was that ears works better with AI. I don't know if that's true. I doubt that they did a hard and rigorous science. I'm assuming that somebody saw it and said, that will work. Let's use it. I'm still in the BDD camp for now. But I like the fact that they're doing this. I think this one thing that Amazon is doing, if this IDE becomes kind of a standard for people, I think is the right thing to do. Specification-driven design. So here's just an example with the shopping cart, right? Given the shopping cart has items when the user clicks checkout, then the payment page is shown. Very simple, given when then. Ears would just say, while the cart is not empty, when the user clicks checkout, the system shall show payment. To me, they're exactly the same. They were two things that were both invented at different times by different people having different needs, but serving the same kind of root cause and need. So I want to talk about an experiment, because I believe this to be true. So I said, okay, well, can I run an experiment? Can I test my thinking at least a little bit? So I did, because I think if BDD truly captures behavior, what we can do, if it's truly that mold that we pour code into, we could build the mold, we could pour the code into it, right? And then we could take, then whatever comes out, I'm always thinking like it's a wax figure of like Leonardo DiCaprio or something. Right? I mean, you could tell it's going to be Leonardo DiCaprio because you can look at the mold and say, yeah, that mold looks like Leo, whatever. Anyway, so you pour that in there. So I could take that statue or whatever I'm creating from that mold, whether it be code or anything else, I can break it. I can get rid of it completely. Delete it all. What happens if we do it? So I did it. So I want to show you what that looks like, because I think it's pretty interesting. So here's the scenarios. I had a bunch of scenarios that I wrote. It had to do with login stuff because my day job is with identity and login. So it's what I kind of know these days. So that's just an example of some scenarios that were created, right? To show it on the slide, I couldn't show it without, it wouldn't normally look like this. But anyways, you can see there's given, when, and then. Given certain preconditions, when the login thing, then certain things happen, right? So I create all these BDD scenarios. There's a whole bunch of them. This is a small experiment. I think there were maybe just under 10 scenarios. And I said, okay, small functionality, Obviously not a huge test, but it gives me acceptance tests. This is all done through AI, by the way, right? I said, here's the BDD scenarios. Give me the code for the acceptance test. And you can see those here. And if you're not familiar with this, this is acceptance test-driven development. This is also test-driven development because what I'm doing is I'm creating my tests first. I have not created any code. I can take those tests, or I can take the original BDD, which is what I did, and I can say, okay, now that I have these acceptance tests and I know that these are the right acceptance tests based on my BDD, I can create code from the BDD. So here's version number 1. I created that code. I took that code, I got rid of it. I said to AI, this is all AI generated. This AI generated code, by the way, right? This is not me. I didn't write this. Take this BDD, take this group of BDD scenarios and write it again. And this is what it looked like. Now, you don't have to be, a fancy software developer to understand that these two things are not the same. Basically, given the same specification, same BDD specification, AI wrote the code differently. And to a certain extent, I believe on a small scale, and I need to do more research into it, and I'd love to see more people doing research into it. I'm sure there's others, not just myself, but here's the question. Different code written different ways to the same specification. If I try to run the acceptance test, does the product do what I want it to do? What happens? Well, when I write them, you can see they're version 1 and version 2. Version 1 passes, version 2 passes. Meaning that based on my BDD specifications, the code may be written in many different ways. It might be written in different languages. We might decide to use Go instead of Java or Python or whatever. I don't care. It no longer becomes that important from a product standpoint. I can make sure that they all pass, and they do. So the code is no longer the product per se, because I can wipe out the product. The product is really the specification, the behavior that I described. So if I can describe the behavior with enough detail in the correct way, then I should be okay. So the real source of truth becomes what I want from my product, which is where it should have been always, I think. And this is not different, by the way. I'm going to say that multiple times. This hasn't changed. AI hasn't changed this at all. It's just other than a human being, I have, if I gave it to 2 human beings, same BDD scenarios, they're going to give me different code. Guaranteed. I give it to AI, it's going to give me different code. So nothing has changed other than I've taken, in some respects, the human out of it, which is where the problem lies, is if I'm not specific enough in my specifications, the human being is going to ask me questions. And I can deal with the ambiguity because I can communicate as a human, one human to another. Can't do that with machine. Right? So the BDD is the source of truth. It's no longer the code because, and this is a fundamental change, not only in how we look at things, but in how things function. Because I could tell you for years and years and years, when somebody would come to me and they say, well, what is our product? I say, go look at your source code. Look at your repositories. That's how you figure out what your products are. Because in the end, your products are the code that you write. This is no longer true, I don't think. Because I can quickly and easily get rid of my product and rebuild it basically from scratch. Right? And if I do it well, I can do it because I'm building quality into the product. I can do it with building quality into the product because I'm not going to let AI run amok on ambiguity. But wait, there's more. It's kind of like an infomercial. There's more to it. This is not all of it. Here's the next question I wanted to pursue. If BDD is the mold, can we build the mold from the code? Think about it. I've got this stack. I got this wax statue of Madame Tussauds Wax Museum of Leonardo DiCaprio. It looks like Leonardo DiCaprio. Can I make a mold from the statue? Would make sense, right? Again, metaphorically, mental model, it makes sense, right? So let's test this thing. I think it's pretty interesting. Can AI help us with this? And this is the place where I think it really, and this is the place where I think everyone should start, by the way, tomorrow. If I had a magic wand and I was king of the world, and everybody listened to me. I was joking with Sadir before we started that I feel like Cassandra in Greek mythology was the woman who would always tell the truth, but no one would listen. But this is where I would start because you have code today. And that code probably doesn't have the kind of mold or safety net or however you want to refer of having BDD. So can we create BDD from the mold or from the code? Can we create the mold from the code? So here's version 1 of the code. Okay, we saw this before. I took this version of the code and I went to AI. This is in some of you are techie people, so you probably want to know. This is in VS Code, and I think it was Claude. I said, read this code and do me a favor and write BDD scenarios for it. And this is what it came up with. Right? You with me so far? So now I have BDD scenarios that match the code that was written. Now I could take those BDD scenarios, I can match them up with the original BDD scenarios, and I could see that there's some slight differences, right? The differences actually from the BDD created from the code, they tend to be more technical in nature. Whereas when I'm writing BDD from the product side first, they tend to be more product in nature. That makes sense. But I've created a mold. The question is, can I take the mold and now create a new statue, right? It's kind of like, can I make a copy of a copy kind of thing, right? And the answer is, okay, yes. And if you look at this code, this is version 3. This code is different than versions 1 and 2. But that's not what I want to prove. What I want to prove is, can version 3 of the code that was basically made from reverse engineering the BDD, the BDD scenarios were reverse engineered from the code. I created new code from it because I had the mold. I created a new statue, and does the new statue work? That's the question. And the answer is all acceptance tests from the original acceptance test passed. I want you to really understand this, right? I take the code, I create scenarios, I blow the code away, I create an entirely new code, I test it against the original specification, and all the scenarios pass. That has there's some, this again, small scale stuff, but I think it would hold over time. Here's what I've come to the conclusion. BDD and code are two expressions of the same truth. It's not one or the other. We can go either way. And because we have existing legacy code, we should go both ways. Because one of the things that we can do is we can take that existing code and we can interrogate that code with AI, and we can say, create BDD scenarios for it. Now, then we can start to create that suite of regression tests, that suite of acceptance tests that keep us safe in this world of AI. That becomes the beginning. And then if we're smart, we know it works both ways. So as I'm making changes to the code, I make changes to the BDD first and then changes the code. But I also have a bunch of scenarios that I've created from the code that exists today, right? To me, this is quite profound. I don't know if you all can see that. If you understand it, if you have questions, I'm almost to the end here. I want to talk about the implications of these things. Because BDD and code are not two different things. They're the same things expressed twice. There are major implications. Now, the first set of implications, which I'm not going to go over in any detail, are the 10 things I talked about before. The 10 reasons why BDD changes everything. Nothing has changed from that. This is still true, but there's more implications now because now we're in AI, right? Now it's not developers doing the code, it's AI doing the code. First implication. In your workflow, you should be writing the behavior first. You should be creating the scenarios first. And that should be, quote unquote, the source of truth, should be the mold, not the statue, right? And here's the fun thing about that. I work with AI all the time. And in fact, both inside and outside my work, all this was done outside the work. I've nicknamed my AI, like I treat it like a human being, and I use it as a thinking partner. I say, here, this is what I'm trying to accomplish. And then I work with the AI to create the BDD scenarios because it's really good at that. I don't just take what it gives me, but I massage it through there. I ask it questions about it. It becomes a thinking partner. This is what I think a lot of folks miss in this rush to make AI replace people with agents and stuff like that, which I'm not 100% certain is going to happen. But in our rush to do that, what we're missing what I think is the biggest benefit of AI, which is it's a thinking partner. I can take an idea, I can bounce it off that because this AI has read everything, right? I feel like I've read everything, but it's read more than I have because it's a machine. It can read anything. It's been trained on a whole bunch of stuff that I'm not even aware of. So using it as a thinking partner anyway I use it to create the BDD scenarios. The next thing is undocumented code, which is the biggest problem. I run into this problem all the time, is that the documentation of the systems, documentation of the code never matches the actual code itself. This goes away, right? Because what we're saying is that there needs to be a intimate relationship between the specifications, which is basically the documentation, and the code itself. So the code becomes self-documenting. And because we can reverse engineer BDD scenarios from the existing code, it is self-documenting, right? This is, to me, if I had to say what is one of the biggest uses of AI that we could do tomorrow that has no potential, I don't think any potential to really harm us in any way. Create BDD scenarios from existing code, create acceptance tests from those BDD scenarios, create that nice framework around it, create that nice documentation around it. Because this is really the issue, right? The specification gap is closed. You're as I was just alluding to, your documentation never gets stale because your documentation is the code and your code is the documentation. They're two sides of the same coin now, which they weren't before and never have been. But we have that opportunity. And I think knowing human behavior, and I hate to say this, and I don't want to be jaded, but I'm an old guy here. I think human behavior, we're going to skip right over this piece, unfortunately. I hope we don't, because we have an opportunity to do something that we couldn't do before. Because when I would go into organizations and they'd say, okay, how do we improve the quality, et cetera, et cetera, et cetera? I say, well, we want to put BDD scenarios around the existing code. I said, well, that's too expensive. We don't want to do that, right? I said, well, all I want you to do is tell me how your system behaves today, and then write tests for it so that we can make sure that anytime you make changes, you're not breaking something that works today. Now with AI, shoot, it's easy because we can read the code and we can write the BDD scenarios from it, and then we can we can use AI to write the acceptance test for it. And there's much more. I'm just going to go through some of the other things, but test coverage is no longer a separate thing, and it never should have been, by the way. So again, this is all stuff that was true when we didn't have AI and is, I think, more true now. Test coverage should be a byproduct of your process, and your process should include writing BDD, detailed BDD specifications for your system. So your test code coverage goes through the roof, has to, but not because you're trying to do that as some kind of number. I've got to, whatever, some kind of metric. It just happens because you're baking quality into your product, right? You can't bolt quality onto your product after the fact. You can't. All you can do is you can find the defects that you've put in there. And if you don't find the defects you put in there, guess who's going to find them? Right? Your customers eventually are going to find them. You don't want that to happen, but that's how most folks do, right? This is again, even in today's age, BDD has been around 20 years. How many people are actually using it effectively? Not many, but it's been shown again and again and again to have all these huge benefits. Onboarding changes. If I got new developers, I don't have to go. I'm old enough that I remember. You got somebody new as a developer. You say, here's the code. I'm too busy, right? Everybody's too busy. That's the other thing in AI, right? We just become busier. We may or may not become more productive. I don't know about that yet, but we certainly have become busier. So, how do you onboard new people? Well, if you have BDD scenarios, you have the description of the code, you can onboard them easily. I'm looking at time. I just want to give, I wanted to give a half hour for questions. So I'm going to wrap this up quickly. Code review shifts upstream. You should, instead of having code review of the code, which you still should have, by the way, but that being the most important part, you really should refine and vet your scenarios beforehand. I was reading something yesterday. People said, well, we're going back to waterfall. No, you're not going back to waterfall. You don't have to vet every scenario for everything that your product does. You can still build incrementally. It's just when you're building, in fact, you want to build incrementally because you don't want AI to go off on a tangent. If you give AI 100 scenarios and say, write code for it, the chances of it hallucinating are much greater than you give it 5 new scenarios and say, change the code to match this, et cetera, et cetera. You're with me. But your code review needs to shift upstream. So all the things that we should have been doing with developers when we talk about refining our work before we actually go off and start developing becomes more important now. There's some architectural implications. One of them is the architecture of the system, right? BDD scenarios become the architecture of the system. We can understand it better. Formal specifications become more accessible to people. And then organizational implications. The wall between business and engineering should get thinner than it is now. It shouldn't be thick today, but it probably is. That's going to start coming down because we're going to shift the burden of the functionality of the system to product as opposed to developers per se, because a lot of the development's going to be done by AI. You're going to have more chance for automated compliance and audit trails and technical debt changes. If you do this, hopefully you're not building technical debt. But here's the thing. Interestingly, all these things were true. They've always been true. It's just now we've taken, we put it on steroids with AI. This is not new. This stuff always existed. It's always been true. BDD has always been a really good way to write code. I think in the future, it's going to become the way, whether it be ears or BDD, I really don't care. It becomes that important. It becomes that critical. And if we don't do that, I think we're going to cause a lot of problems. We're going to build a lot of technical debt. We're going to have a lot of ticking time bombs. And I think that that's really problematic. In fact, I would say that it's dangerous. And, I've often said that I'm waiting for the lawyers to call me to the stand for reckless behavior. I think that if you're not doing this, it's reckless, especially with AI. It's reckless now, but it's with AI, it's going to be even more reckless. So somewhere along the line, that when you got to pay the piper, I'm not going to be surprised when companies get sued for not starting to do these things. Because I think we're going to see, you hear the term AI slop a lot. I think we're going to see a lot of AI slop. Don't be part of that. There's ways that we can keep from being that. Biggest shift of all, I think, are the mental models and lenses. So this is what I talked about before. These things, the vibe between software, between product and developers, it gets thinner and thinner and thinner. I think it truly represents a different way of thinking, a different philosophy of how software is created and delivered. And I think we need to make those shifts. But those shifts are mental models and lenses. Those shifts happen here. AI is not necessarily going to help us with that. We have to help ourselves with that. But is this anything new? I'm going to propose it isn't. I'm going to propose that it always has been how we see the world and how we perceive the world. And we have the ability to perceive it differently. The mental models and lenses we use is how we see the world is fundamentally what's going to give us either success or failure in this AI age.